as it was introduced, my name is Luca. By day, I'm a machine learning engineer in this wonderful company named Extreme. We're based in Milan. We do AI solution and digital products, but more on that later, because by night I try to either sleep poorly or just be an open source maintainer. Raise your hand if you maintain your projects during the night. Okay, I see a couple of poor souls. We have like a counseling session outside. Okay, we can reach out. It doesn't have to be toxic. I am a really huge time series enthusiast, especially about forecasting. And it is a wonderful problem. It has one problem: scale. And the problem with this is really important, because back in the days, doing forecasting was tedious and error-prone, and it was a work of a tailor, as I used to say. So you have to take your time series problem, your time series data, analyze it, analyze the residuals, and carefully fit a model on that. And that scales really poorly, because you have to really easily go into a cluster, into a PySpark system, or do something distributed just to fit thousands of time series, for example. That's the case of, I don't know, Spotify, which actually does it for millions of time series. They were doing a talk years and years ago where they were using basically a distributed system to fit auto-RIMA models. Actually, they were using Prophet. But to just provide demand forecast for the listening, the amount of listeners of every song. This doesn't scale, and this can only, people like the 10% only can allow to do this. But it's actually a lot of engineering and manpower required to address and tackle these kind of problems. The point is that now we have a wonderful library, which is Polars, that we talked about extensively today for 2 talks, a keynote and a talk afterwards. So raise your hand if you know Polars. Okay, clap if you like Polars. Okay, I thought you would like any more, but nonetheless. And so here is functime, which is a library that Christopher, the former creator, and now is running a Y Combinator startup, is doing. But more than a complete forecasting library, is more of like also an example, a feeling, like, you know, a vibe of what you can build and Polars can enable you to build, which is something for the reasonable scale, for the 90% of the people, which is really important. And so today we're going to talk about, briefly we mentioned the problem with forecasting, how we try as functime to grab an answer to that problem. What is Polars? I think we can skip that section, but maybe we can summarize it fairly well. And especially what is global forecasting, which is a really powerful technique that functime uses, that was used across, like, the rose to popularity across in the last couple of years to tackle precisely this kind of problems. And finally, we'll do an endeavor in a dangerous live coding activity, because we like risk, and of course we really like making mad the demo gods. And finally, we have a couple of observations and references for the people that stay alive after that. So, this guy knows a couple of things more than I do about time series forecasting, okay? He was in the board of directors of the International Institute of Forecasting, and was working for SAP for quite a while. And he said that we spend far too much time and resources dedicating to forecasting problems. Our forecasting workflow, as I was explaining before, is really demanding in terms of the mental effort that anybody needs to put in. Analyze the residuals, see if the residual distributes somehow, fit a model here, fit a model there with other parameters. The whole forecasting workflow is not just model.fit, okay? Even well before the productionization, okay? The effort of this whole thing is about in reading the data, setting goals, finding the requirements, finding the appropriate model, finding the seasonalities in your data. It's really demanding, because you have to do it all over again for all of different time series, because they're different in nature. And so when we think about forecasting, we shouldn't actually think of the cost of forecasting in terms of the resources, but as a whole machine learning effort. And this process, Mike Gilliland argues, needs to change, needs to become more efficient and streamlined, okay? Because when we want to provide, especially like as a commodity, like forecast at scale, we need to be able to deliver forecast quickly. And basically what we want to do as functime, which is a forecasting library based on Polars, is to bring this kind of efficiency for the 90% of the people. Not for Spotify, of course, but for regular people who address forecasting problems, forecasting, from electricity generation to regular things, with a clear, concise, and API, even that allows you to forecast thousands of time series at once from your machine. I have like, this is like a beefed up machine, okay? This is like 36 gigabytes of RAM, thanks to my employer. But I mean, that could also work on a lot of machine, and that was kind of Richie was hinting at this morning with his with polars. You can do forecast at scale with thousands, hundreds, but actually thousands of time series from your local machine. And you don't need distributed systems. You don't need a cluster. You don't need to do any of that. And you need to enter that kind of dangerous things. As functime, we also want to provide you a feature engineering and diagnostic API, ever expanded to tackle this kind of forecasting problem, which doesn't mean that you have to manually inspect the residuals of every time series and write the code for that or write an ugly for loop. That we do that for you, especially with the feature engineering side. Actually, that bit does polars, but still. And finally, we'd like you to smoothly translate from experimentation into production, of course, because as it can be run on your machine, it doesn't need to be scaled to a cluster, but it could be an EC2 cluster, for an EC2 machine or a virtual machine in a remote container. You don't need to set up a whole cluster for that. And this, we argue, can be simply and swiftly achieved with two tools. The first being polars, and the second one being global forecasting. So without further ado, let's go and skip the polars description. Because polars is basically a front end, a data frame front end to a vectorized query engine, multi-threaded, truly multi-threaded, really optimized, unlike unlike pandas. A data frame front end means you interact with it with mostly a Python data frame object. It uses all core and efficiently. It respects 50 plus years of relational database development in optimization of the query engine. And finally, it is in process, a bit like, raise your hand if you know SQLite. I expected everybody to raise their hand actually after this one. Does anybody know DuckDB? A bit less, okay, it's basically just polars, but the only SQL. And finally, LansDB, which is the underdog here, which is a non-in-process vector database. If you do a bit of LLM and generative AI, as I do in my day-to-day work, I highly recommend you check that out. And what makes polars so fast, we should know by heart by now, and I should gloss over this one, because if I missed it, Richie will break my ribs. Actually, we should edit this part, it's a bit too much. But it's really efficient, it does a lot of query optimization. For example, if you do this in polars, basically it will be optimized so that it just takes like the first 5 elements of the row, whereas Panda has to sort the whole thing array and then take the top 5, which means that polars is really efficient in a way that it reads data so long as you use the lazy mode. And then we go to the other bit, global forecasting. So we had a keynote about polars. I summarized it very briefly, but what can I say about global forecasting? Turns out I don't need a keynote for that. I can just tell you just fit a single model on the whole set of data frame, of all the set of time series that you have. Given a panel of 100, or like a dozen, 100, or 1,000 of time series, you can just fit one model on those, and it will work. What's the juicy sauce? Did we implement any new fancy forecasting algorithm? Of course not. We use gradient boosting trees. And this is basically the TLDR for most of tabular machine learning problems, but it works fairly well for time series as well when we try to forecast a panel of time series. And keep in mind, throughout the past years, we've had forecasting competition as well as other empirical papers that try to assess whether global forecasting was a thing, and it is. So maybe you need to fine-tune it a bit to tweak and obtain and squeeze the last drop of performance and reach state of the art. But as far as we are in tabular data, both regular and time series, just gradient boosting all the way. So, I mean, it's really easy to get state of the art, okay? But still, it's really easy to get a great performance with a model fitted on the whole set of the time series that you work with. And see here how we address the two major bottlenecks of this whole theater. The first one being feature engineering at scale for thousands of time series. The guy here made it and solved the problem for us. Bye. Oh, okay. It's really hard to keep the energy up. The second problem is fitting, because eventually you have to move from a polars data frame to NumPy, basically, because scikit-learn or any other forecasting library uses that. And you need to do the conversion, and then otherwise you cannot just fit over every group a forecasting model. And this is what the literature basically and empirical facts showed us. We can just use one and fit on the whole set of forecasting models of all time series, and then achieve pretty decent results. And Basically, this is the recipe about functime, and a powerful query engine to perform blazingly fast feature engineering. That's blazingly because I need to use it because basically there is a bit of rust under the hood, and then followed by a single model.fit. But the point is that functime doesn't offer the best model, but aims at offering you the best developer experience. And we not only exploit polars for feature engineering. It turns out that given it's a parallel engine, it makes cross-validation for time series forecasting, also known as backtesting, extremely easy because it's just a sliding window, and so polars can parallelize the generation of those data frames very easily, and then we just fit the model on those. So it's faster than it would actually be if you had to write that hands down or the usual combo like pandas plus scikit-learn. This is not to dump on scikit-learn, of course. And here we enter the very dangerous part. But it turns out that unlike Marco, I don't know how to exit full screen. There we go, okay. But I ran all the code beforehand, so I know where it fails and where it doesn't. Actually, this thing raised an error before, actually frozen, because I was trying to put the image into this notebook, but I realized there is a limit of data that you can put inside basically a notebook before the page becomes unresponsive, and voila. So here's functime. We have a nice logo. No animals yet, because how can you make an animal out of a crystal ball? But, and I did a bit of a trick. We made a release last month to update it to the latest polars version, but a bit of code broke, so here we're using not the latest one. I have something to do for tomorrow's sprint session, so in case anyone is interested, please reach out. We can arrange one impromptu and do it all together. But basically, you see functime is important as functime. We go against every tradition. We don't need any aliases, but if you need one, you feel free to open up an issue and say if we should be imported as FT or something. Would actually be a cool one because it gives you a bit of a more like a status, but whatever. Maybe it also gets you a sue, right? I don't want to open my door and see a lawyer from the Financial Times saying, hey, you shouldn't be using that. That's trademark it. So as it turns out, we're using a bit of an older polars version for this functime version, but it doesn't really matter. And we're also using this commodity data set, and this is the entity I've been talking about for this whole time, which are basically panel data sets, or basically data frames. We have multiple time series. There is like an entity, or entity type, or a unique identifier. If you do forecasting of retail goods, it's called SKU as well. Don't tell me to unwrap that one. I will raise an error. And then there is the time error, the column, and then there is the price column, basically the target variable. And this is the only assumption that we make about the data that we get as functime. Func stands for functional as first, but I'm also thinking about offering like a time series data frame API. You can talk about that and think about it late afterwards. But basically, this is the only assumption that we make, that the entity column is the first one, the second one is the time, and it has to be ordered, and the last one is the target column that you want to make. And you see here that the challenge with this problem is not only about the fitting, but it is also about the exploration. And here, for example, we have methods that allow you to explore the cardinality, the number of observations that we have for each of these time series. And you see here that we have approximately 70 time series about the price of goods since, I don't know, 1980 something until the latest year of where we have observation, and I think it is 2020 something, 23, post-COVID, okay, which is a new era on its own. And and you see here that we are starting to get a feel for the complexity of working with so many time series at once. It's not just about fitting a model, but just understanding them as a whole. And so we offer a bit of this code. It will be actually integrated in the new functime release once I made it working. But you see here we also offer functions to plot those by samples, so you don't have to do them by yourself. You can plot a sample, you can choose what indexes that you want, what like tickers, for example, that you want to display. And here we see 6 random time series, for example, and we can explore them. We can see the patterns, we see the trends, we can see the discontinuities. And we can do the same if we use our ranking functions. This is a really common measurement that is used to basically explore the variability of time series, especially in a bunch when you have a bunch of them. And it's basically just the standard deviation of the time series divided by the mean. So you kind of get, if a series has a long, like a really big variation, but a really high mean, it kind of gets scale them, so you can rank them. And in this case allows us to sort the function and see which ones have the biggest coefficient of variation, which is basically, let's just put in this way, normalized standard deviation. And we see that coal rose in price significantly during 2021, and then fell down going into 2023. And we kind of understand why. We see here that it was due to a war. The phosphate rock is also, I think it was also due to the war in Ukraine, because phosphate was used as a fertilizer as well. I think Russia produces a lot of it. So you see how complex in nature this problem are, and what kind of tools that we would like to offer to you as functime is not only the tools to be extremely fast as model fitting or as your transformation pipeline, but also in exploration. And when you go on, you see that we also kept a really familiar API, which is the scikit-learn-based API. So you can create a splitter, and that splitter will just split the data in training and test it. But under the hood, it will do it and deal with the complexity of this whole thing for you. So you see here that we created a test set that contains basically that gathered all the time series and took like 4 elements for every time period. If you did this in scikit-learn and you would define just a splitter, you would just have like the data set split in 2 at a random point. You would have to do like a group by or do that manually. We handle the complexity of working with multiple time series at once just for you. And that's basically all it takes to do the forecasting. And as forecasting practitioners, it's really hard. Marco knows it very well, because not only is a great presenter, but he's also like a great forecaster. That the first forecast that is really hard to beat is the naive one. Moment of silence. I felt like I needed some time to let that sink in. Seasonal naive forecasts, even like moving averages sometimes are all you need, okay? It's not attention, it's just seasonal naive, right? All you need. That doesn't mean you have to get distracted by now. Sorry, I need to make bad jokes, or dad jokes, which is even worse. And you see here that the naive forecaster, the way we train it is just a dot fit, where y is the training set, and the production, actually the prediction, sorry, I'm already thinking about deployment, is just predicted next steps where the forecasting horizon is basically the number of steps into the future that you want to predict. And when we do it, you see that we did, and we do the whole aggregation and fitting the model on every time series when it's needed or when it's not, and generating the prediction for every bit of them. We abstract the complexity of generating those. Even if you use, for example, scikit-learn to train a model on this whole set of time series, then you would have to pass the training set and make the prediction for one. We abstract away the complexity and generate the prediction for every one of those time series for you. And here we come to another period, like the thing that I really liked, the diagnostics. The same way we offer them for exploration, we offer them for diagnosis of your time series models, and you can predict the forecasts and you expect. You see here in gray is the actual value. On the top you have the prediction, and you can inspect them randomly, but you can also sort them according to a certain error metrics. Here, I'm actually doing a bad thing. I'm using the mean absolute percentage error. Don't use that. By definition, the mean absolute percentage error is defined as basically the forecast error divided by the true one. And when basically it's y hat minus y high, y hat high minus y high divided by y high. And this is bad because when y high gets to 0, the error explodes. It's a really sexy metric because you can tell the business, hey, this metric, this forecast, that has 3% error. And you're like, wow. But actually, it can blow up in your hands really, really well. So I will link in the notes some description to better forecasting metrics, but still, you need to be a bit more thoughtful about the metrics, and we offer a bunch of them actually. We have these, you see here, we have a rank bench point forecast. This actually was a data frame that they generated. We have like a rank point forecast, basically a function that sorts, just basically sorts the data set according to a certain metrics. And here it's mapped, but it could also be something more useful, such as the mean absolute error, for example, or the root mean square error, which actually have like a geometric representation. And we can, but anyway, we can still sort them by a certain error metric, and we can see which one are the time series that behave worst. In this case, the potassium chloride and the natural gas. Who would have guessed? And here, it's where the juicy bits come. The global models I was telling you about. And here you can see a bit of the expressiveness of functime as a whole. We went a step further and didn't stick with the scikit-learn API, and I really like this choice, and basically I am in this project just because I really liked this feeling that I got from see that when we fit a linear regressor, in forecasting you don't do the same feature extraction for the same models. Some models might accept different transformation. Basically, we allow you to import just as you would in scikit-learn. You fit a linear model, you see the frequency, because you need to know the frequency of your data because we can aggregate it. So if you have daily data, you can make monthly forecasts, for example. You can specify the number of lags, which is like the lag, the regressor that you use. The target transformation, so the transformation that you can use to transform your Y, and the feature transformation, basically the feature extraction methods you want to use. And these can be any list of, because you can apply multiple of them. We'll take care of storing the metadata and reapplying them when you call .predict. And you see here, for example, that we use a rolling window. So basically, we computed the mean and the standard deviation for every one of those window sizes. This is a popular method that was used to obtain great accuracy and win forecasting challenges in auto presentation. And you see here that the forecasting works really well. We can provide those a bit of, we can compute cross-validation intervals as well. We can also offer, though, other forecasting, so other error metrics and other diagnostic tools. I really like this one that plots the distribution of residuals across all time series, but we also had another one where we can see, okay, here we fit a gradient boosted model. It doesn't perform as well, spoiler, so know your time series, don't just go for the big guns at first. But we can also have these plots that I really like, called forecast value added, which tell you a bit about which model behaves best as a whole, where every point is individual time series. So you can explore and see what time series behaves better and best. I think I will go through this afterwards if you're interested, but it's the really powerful visualization which allow you to say whether the model that you fit is best for a forecasting metric. Just choose one. You don't need to be the best among three because they have different interpretations. But still, they can tell you whether your model is good or bad compared to a baseline, for example, and which models, which time series, for like which individual entity your model works best. So you can do some specialized feature extraction for those features. And the Comet plot does this basically the same thing. And so this is it. You can find it at functime.org. I'm Luca Baggi. I'm glad you to keep in touch with you. Please scan the QR code because we are modern guys that we use those. I would love to share any feedback about you. If you really want to talk about functime, we can get in touch and arrange something for tomorrow. Thank you very much for a wonderful audience.
Thank you so much. All the questions are in the Discord. You can chat with Luca.